Hello students, we have studied Archimedes principle in the last videos. In this video, I am going to explain you how to calculate the relative density or specific gravity of a solid by Archimedes principle. Let's take the example problem number 1. Here it is asked to find the specific gravity Sg or relative density of solid. Keep it in mind, solid, if it weighs 150 grams in air and 125 grams in water. The solid weighs 150 gram in air and 125 gram in water. You observe the diagram. Here I have given the solid is weighed in air with a spring balance and it is giving a reading of 150 gram. When the same solid is immersed in water attached to the spring balance, it is giving a reading of 125 gram. That means the solid has lost almost 25 grams of its weight due to upward thrust experienced by the solid here. Upward thrust experienced by the solid. So, how to find out the specific gravity of solid in Archimedes principle is having a simple formula. Specific gravity of solid equals W1 divided by W1 minus W2. Again coming to the this one diagram, W1 is the weight of solid in air and W2 is the weight of solid immersed in water. W2 is the weight of solid immersed in water. W1, as per the given problem, the weight of solid in air is 150 grams. That is 150 I have taken here, and W1 again 150, and W2 is the weight of solid in water. Weight of solid in water is 125 grams. So 150 divided by 150 minus 125 gives you 25. 150 divided by 25 you get 6. That means the specific gravity or relative density of solid weighing 150 in air and 125 gram in water is 6. So in this way we can apply the Archimedes principle to find the Sg or Rd of solid. Let's take some more example of this type. In the second problem, it is asked a piece of metal has specific gravity 8. The metal specific gravity is given, it is 8, and it is weighing 400 grams. Weighing means it is up in the air. Its weight is 400 grams. Absolutely, it is in the air. If it is immersed in oil, it is immersed in oil with specific gravity 0.8. Specific gravity 0.8. What will be the weight of this metal? Here it is asked the metal is weighing 400 grams in air. If it is immersed in the oil of 0.8 specific gravity, what will be its weight? That means you should lose some weight in the oil. To find that, we have the formula, that is specific gravity or relative density. Specific gravity is also called as relative density. So the specific gravity of metal divided by specific gravity of liquid is equal to W1 divided by W1 minus W2. As per the given problem, W1, the weight of solid or metal in air is 400 grams. That's what W1. And W2, that means the weight of solid in the liquid W2 we have to be calculated. I have marked the question mark here. We have to find the W2. For that we have the formula specific gravity of metal divided by specific gravity of liquid equals W1 divided by W1 minus W2. Specific gravity of metal is given, it is 8, and specific gravity of liquid is also given 0.8 is equal to weight of metal in air is W1, it is 400 grams divided by weight of metal is 400 grams in air, and weight of metal immersed in the liquid W2 we have to be calculated. Just my cross multiplication, we get W2 equals 4000 minus 400 divided by 10. 3600 by 10 we get 360 grams. That means the 400 gram metal weighs 360 grams in liquid. That is, it is experienced by upward thrust hence the weight of metal is decreased from 400 to 360 gram in the liquid. So let's take one more example of Archimedes principle. The third problem, it is asked, a liquid has relative density 0.8. Liquid has relative density 0.8 and a piece of metal weighs 80 gram in this liquid. The piece of metal weighs 80 gram in this liquid. If the same metal weighs 100 grams in water, the same metal weighs 100 grams in water, find out the density of metal. Find out the density of metal. We have the formula from Archimedes principle for solid. Hg of metal divided by Hg of liquid equals W1 divided by W1 minus W2. So what is Hg of metal given is 8. That has to be calculated. The Hg of metal, let x be the Hg of metal. I have taken here, let x be the Hg of metal. So x by Hg of liquid is given, that is Rd or Hg 0.8. 0.8 equals W1 weight of metal in water we have to take. W1 is the weight of metal in water divided by W1 minus W2. W1 again water, W1 minus W2 is the weight of metal in the liquid. That is 100 divided by 100 minus 80. By simple mathematics, we get x value as 4. That is, the Rd or Hg of metal is 4. Hence, Rd of metal is 4. So, in this way, we can calculate the Rd or weight or Rd of different type of metals by using Archimedes principle of finding the Rd of solids. So, in the next video, I will give you some simple problems on finding Rd of liquids by Archimedes principle. So thank you. Thanks for watching.